Okay, so now these are going to be orbit problems, right? So in an orbit problem, we say that gravity equals the centripetal force, okay? Or if the box is sliding, right? Okay, so gravity is always g mass of the central body, mass of the satellite over r squared. And then in this case, we want to use, since we have the period here, right? That's the period. So we want to use the mass of the satellite times 4 pi squared r over t squared. Okay. Now, this thing is not in your data packet. This is in the data packet, the force of gravity, right? This formula for centripetal force is not in the data packet, nor is there the notion that we set these two equal. So either memorize that or have it make sense. That's supposed to be an r right there, right? 4 pi squared r over t squared. Okay. Now this is the reason why this is centripetal force is that that's mass times and that's acceleration, right? So I'm really using F equals ma, right? Okay, and then all you do is you substitute either v squared over r or 4 pi squared r over t squared in for that. Okay. Now, what I think you should do is solve this for the variable first. Okay. So we're going to solve this. We want to know the mass of the central body, right? Notice that the spaceship's mass just canceled. That's the satellite mass, right? Okay, so we're going to solve for mc here, right? And if I do that, I'm going to take the r squared and put it up there and put the g down here, right? So the central body is equal to 4 pi squared r times r squared, right? And then divided by gt squared, right? So 4 pi squared r times r, right? That's going to be r to the third, right? Okay, that's our central body. So there we go. So I'm going to type this into my calculator. 4 times pi squared times the radius, 1.16. E7, and then that's actually raised to the third power, r times r squared. So I'm going to go raised to the third power, right? And then I'm going to go divided by, and I'm either, if you've got a calculator that does the fractions, definitely use that. If you don't, then you have to go divided by, put this in parentheses. Otherwise it will divide by g, multiply by t squared, right? So I'm going to go left parenthesis, 6.67 e minus 11 times t squared, which is 17,500. So times 17,500, and I'm going to square that like I'm supposed to. All right, here we go. And I'm getting 3.016697 times 10 to the 24th, right? Which is, if we had to round to there, we'd say 3.02 E24 kilograms. Okay. I'm gonna, if you write scientific notation that way, that's fine for me. Probably for the IB test, one had better write it this way. Just because they might think that that's not proper.